why don't we take a look at example 8 together? I want to help you unpack it a little bit before I have you finish the problem. Let's read through this line by line. It says, a car is being driven at a rate of 40 miles per hour when the brakes are applied. My first question for you is, when you see this 40 miles per hour, is that a position thing, a velocity thing, or an acceleration thing? What do you think? Position, velocity, or acceleration? I have 1 vote for velocity, 2 votes for velocity, 3 votes for velocity. Okay. My question is, how do you know this is velocity? What's the clue? The units, miles per hour. Great. So this object here, this is velocity. And it's 40 miles per hour. So when you look at that, that's a rate of change. Acceleration is also a rate of change, but it would have different units. It would be miles per hour squared. So we know it's not acceleration, it's velocity. Is there any questions about that, first of all? The second thing I want to say is, take a look at this. It says, when the brakes are applied. So what I claim is that we're going to have t equal to 0 be when we first step on the brakes. So when the brakes are applied, that's t equal to 0. Does that make sense? So from that moment we step on the brake, our car is going to start to decelerate. So in light of this, how would you guys describe this 40 miles per hour? We could write an equation that describes 40 miles per hour that incorporates this idea that when the brakes are applied, that's time t equal to 0. Can anyone type an expression in the chat box that captures the information of this entire first sentence? Please. So I want something equal to 40 miles per hour. I'm saying, what should that something be? It's related to velocity. Great. Right, I could say that v of 0 is equal to 40 miles per hour. That is correct. Okay, so they're telling us the initial velocity. Let's read the next line. So it says, the car decelerates at a constant rate of 10 feet per second squared. I think we can represent the second sentence with an equation as well. Does someone want to express the second equation as a sentence in the chat box? That would be great. You have to first figure out if it's a position thing, a velocity thing, or an acceleration thing. And then you have to write a little equation there. Anyone have a breakdown for the second sentence? All right, I see 3 answers. The first answer I see, which you can't see, has the wrong sign. The second answer has the right sign, but no units. And the third answer, which you can see, is basically correct, but it has the wrong sign. So I claim that what they're telling us is that the acceleration is equal to negative 10 feet per second squared. Ken, is it obvious to you now that you see it, why the acceleration should be negative? Good. I hope that the key word we see is decelerates. So decelerates means that the acceleration is going in the opposite direction of the way you're traveling. So if you're traveling from left to right, and then you have positive acceleration, you're going to go faster and faster. That's acceleration. But if you're going from left to right, but your brakes are slowing you down, that means that the acceleration is going in the opposite direction. So the sign should be negative. That means you're slowing down because the signs are opposite from each other. Okay. So this question says, how long before the car stops? So what does it mean for the car to stop? What do you think it means for the car to stop? Is that a position thing, a velocity thing, or an acceleration thing? I think it's a velocity thing, right? It's basically when the velocity is equal to 0. So here's what we're going to do. We're going to start with our acceleration function. That's -40. And our variable of integration is going to be times. We're going to put a dt here instead. I need you to figure out what the velocity is, what the velocity function is. Then I need you to set it equal to 0, and I need you to solve for time. So I'm going to give you a couple moments. Sorry, -10, not -40. Thank you. So I want you to find out the velocity and then solve for time. Okay. So take a couple minutes to do that. We'll finish this problem and then we'll take a break before we do the next section. Oh, sorry. Student asked, why did I set a of t equal to the integral of -10? I should not have done that. I meant to write the opposite. I meant to write the acceleration is -10 feet per second. I was trying to find the velocity, so I meant to write this. And I wanted you to solve that. So that was my error. Kind of a bad error, actually. So the antiderivative of this should be what? It should be -10t plus c. And now I need to find out what c is. But I know the initial velocity, right? If I know the initial velocity, and this guy's v of t, that I could plug in a v of 0, I would get -10 times 0 plus c. But my v of 0 is what? Well, we just said our initial velocity was 40. So this should be 40 is equal to c. So this tells us that our velocity function is -10t plus 40. What I want to do next is I want to now use that velocity function to solve for time to see when the velocity stops, when the car stops. So I'm going to set 0 equal to negative 10t plus 40. This means 10t is equal to 40. This means t is equal to 40 over 10, which is 4. And my units for time are seconds, so this would be 4 seconds. Does that make sense for everybody? Any questions? All right.